Hello everybody, how's it going? Welcome to another stream. So, in this stream, hopefully we're going to get the BVH Traversal working today, hopefully. So end of last stream, we got to a place... Oh, there's too much stuff on my desk. Give me a minute. Alright, there we go. So, yeah, basically we're trying to ray trace against a tree of ellipsoids. Let's make the tree very simple. So this green one is the parent node, and these white ones with red around them are child nodes. And as you see, our parent ellipsoid is not containing the child ellipsoids. So I asked the question on the Discord to see if anyone could help. How do we produce an ellipsoid from the parent? How do we produce an ellipsoid which contains all the child ellipsoids? So the way we do it currently is we just do the same thing as you would with an axis line bounding box. But the problem becomes apparent when... Oh shoot. There we go. Yes, the problem becomes apparent, whereas you see, like if this was an axis line bounding box, this would go straight down to here, and then it will go under there. So perfectly wrap around, but because it's not an axis line bounding box, things just, you know, they're within this sort of curved part of the ellipsoid, just will go out of bounds. So I asked around in the Discord, and Albert here come up with he was basically saying just do the AABB approach, but then just multiply the half dims by the square root of 3 because it's in 3D. But if it's square root of 2, if it's in 2D. So apparently we should... Hang on a minute. So obviously we'll make that compile time constant, but we're just checking it. So this should now house, obviously it's going to be a bit bigger, but it doesn't matter. Right, it's definitely got bigger. I don't know what happened there. Oh shoot. Sorry, give me a sec. The min is now messed up, isn't it? Right, so scale the final half dims by... Wait a minute, is that right? Yeah, I think so. Wait, would you do it before or after? In this case, it's fine to do it after, I think. Right, so it actually looks like it's housing all of them there now, but I don't know, that one's not actually. But yeah, there you go. So that's probably housing them. But as you tell, it's a little bit too big. But that's the price you pay with this. Let me try something else a second. Let me do it. Wait, where's the square root of 3? Right, there it is. Let's get that into a nice local. Yes, this is when we make the quad tree of the BVH. Right, square root of 3. Yeah, so when we produce the half dims, which is yeah, scale it by the square root of 3. Okay, so if we get this here, rotated. That's the reason why I wasn't looking fine in the for the other one, I reckon. Maybe. Right. Um no, I'm not sure you'd do it. Yeah, I think you just do it once at the end. It's the same thing. Like we had it. Yeah, no, it's a bad idea. Right, so we keep that square root of 3 thing there. So how do we compute the parent? It's here. So this is the debug visualization in the shader. We want to do it in... So this is when we actually build it. So while we're not the root node, traverse up the tree. If we're a leaf node, just fetch it from the array of ellipsoids. But if we're a parent node, then go over all the children and extract out the node tree. And then... Right. So we should... Wait, where's the... I can't see the green one anymore. Oh, U32, damn it. Whoops, F32 for float. Right, so if this one it seems okay. I wonder what the... So let's look at the debug code again and see what it's doing. So it's saying for the root node, because it's at the end, right? When it's actually reached here. For the root node, yeah, go over all the children and do the drawing, the debug draw. Oh, this is done regardless, isn't it? Hmm. Okay. Right, so let's take a look at... So the rest of the tree is just drawn while we traverse up the tree, and the root one is drawn a second time around with the red. All the children are red, and then the root node is green. So if we increase the tree to have 5... So the green still encompasses all of it. Well, no, it doesn't actually. There's that problem there. It's pretty close, though. But why? What, is that a... If it's rendering the children, they're as red. They're quite small there, right? There's 2 of them. But then we've got this real big one here. Oh, you know what it is? This big one here is just a duplicate of the root one, maybe. No? No, I don't think that makes any sense. It's a different shape. Right, so I think we need to somehow debug this better. So let's get rid of our extra debug drawers maybe and just see what happens. No, you still have to draw these ones. Right, so your min-max. Center position. Applying. Right. So I don't think we copied this up here to the actual implementation. But we haven't got any rotated ellipsoids yet anyway, I think. Yeah, still a bit of a bugger. That green one isn't the most outer. So what would be nice to know is... So we can color them in some way. Where's all that sort of dust? Right, it's when an ellipsoid is super thin. Pretty funky. Okay, so what's the next best thing to do? So we need to somehow visualize what layer we're at. So all of them should be at least colored the same way. So how we can know that? So this goes up the tree and we should be able to get a BVH node index, right? So I think, I don't know if I have one of these yet, but I should make one. Maybe I'll put it in the engine. So I basically want a nice random color thing. So we'll just write one out quick. So we'll just be like GPU, nice color, from a UN or something. So we're just passing a random value. So what we should really do is use HSV, right? Hue saturation value. So we produce some HSV value. So the hue is going to be, so the best thing well, the easiest thing we can do is if we just take the constant from the FNV hash, just take one of those big old big primes, right? Or that one. They're both prime numbers. I think it's a prime. Oh yeah, it will be prime. Yeah, so we say V times that. And then what else can we do? This will get us a random hue. Yeah, what does the hue have to be in between again? Is it 0 to 1 or? I think it's 0 to 1. So that would then mean we just say maybe cast it to a float after. I think that'd be alright. So there's your hue. So you want your saturation, let's just say 0.75 or 0.65 maybe, I don't know. And then how bright it is, probably somewhere about the same, I guess. I don't know. We can tweak that. So I think we'll just call that hue. And then what we need to do is return some kind of right, what are we trying to return exactly? We just want it as a UN, isn't it? But yeah, so I guess we'll just say one of them. So hue, saturation, value, alpha, and then we want to pack the result. Boom. So now we've got this nice little function, which takes a U32 in and will give us a nice color back. So that would be super handy when it comes to this. So I think when we're trying to color these things here, right, you can know based on your parent node, hang on a minute. Yeah, I think you can know based on your parent node index and then round it down to the nearest 4 or something, just, you know, and the bits off. There's the color. So we'll just say build parent and we'll and off the first couple of bits. So that's 3. No, not the parent one. The oh wait, we could just use the parent one. Yeah, if we use the parent, that should be enough. Okay, so now they should all be colored. All the siblings should be colored the same. And they should be nicer colors. Although it's not going to draw the parent one, but I'm going to put the parent one as green. And we won't bother drawing the children nodes there. Okay, so we should have a better visualization about what's going on here. So the green one is apparently the most root node, but obviously it's failing in that case. So these are all shown up as a sort of a red color. These 4 children here. And if we just increase. So right now we can tell what's going on. So you've got these blue ones, these 4 here. This red one, well, there's 2 red ones. But there's only 5 nodes. So yeah, something is quite fishy here, because this green one I draw at the end, but as we go up the tree, we're getting some extra. Right, so there's 1 there, 2, 3, 4. So you can see there's 4 there, and there's 1 there, and then a root node. But the root node should never get visited. So what we can do is we can debug print out and just see the numbers that we're getting. I'm going to disable the one of the... Let's delete this code. Well, let's if it out for a sec. This is just some, at the bottom here, I've just done everything just so we can fetch the root node out and display that. And I want to make sure that's not getting in the way of the results. Right, let's just bring this down. That's fine. 1 up. Yeah, still got the same problem, right? You got these 2 red ones, but there should only be 1 sibling, right? Don't know what's going on there. So we've got some printing code. We can take that and move it into place wherever it's gone. Well, I can't see it. So let's just right, here we go. We'll copy this. Found node index. So let's see how many of those that it finds in a frame. So, ooh. Zero, 3, 4, 5, 6. The 0 is not found because that's the root node, that's fine. 3, 4, 5, 6. Right, so we go. So we should be finding 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. So why am I seeing this? Yeah, so I don't know what's between a frame, you see. But I thought we had stuff just printing. Hello? So CPU side, we should have some stuff printing per frame, so there should be a gap at least, right? So what's all of this? Oh, sorry, that's expected, I think. Oh, that's in the initialize function. Don't mind me. Render frame. Drop that in there. See what's going on here. Right, here we go, we've got a gap now. So, wait. Of course there's going to be 2 red nodes. Of course. I was just counting the children for some reason. Yeah, the reason is because obviously one red node parents. Right. Okay. So this red node parents. Yeah, these nodes parent this one. So obviously this 3 is this outer one here. And then this 8 is this one here that's just on its own. So the green one, right, it's going to enable that code again. The green one, right, children count. Destination node index. It must be fetching the wrong. Something about it. Destination node index should be 0 for the root node. What are these things? Oh, why did I do that? Children count. So it should have a couple of nodes. Oh damn, it's disable code, isn't it? Hey there, Andrew. I'm new to graphics program, and I've read several articles on OpenGL.com, and I'm stuck on VAO, VBO, EBO. Yep. I know they're needed for OpenGL State Machine, but I have deeper questions. What if the larger number of vertices are 5,000? Can I have one VAO and VBO to render my object? Yeah. So basically, yes, the VAO thing, I typically try and avoid it when I've done OpenGL in the past. But yeah, the VBO is where all the vertices go. The VAO is just the array. It's a buffer on GPU where it just has a bunch of vector 3s or 4s or whatever it is, your vertices, right? And you just have an array of those guys like that, right? That's your VBO, your vertex buffer object. And you're uploading this thing. The EBO is just an array of indices, right? It's the element buffer object, I think. So that's just another array in GPU memory where you're just uploading a bunch of indices that refer to this. This one would be index 0, this would be index 1, this would be index 3, this would be index 12, which is a bit further down the list. And you'll just, 3 of them make a triangle, and the next 3 make a triangle. But the VAO ties all of this together, doesn't it? Because you can actually have multiple. Yeah. The VA is a bit confusing. What if I have a large number of vertices? Can I use one? Yeah, so you're not limited by the number of vertices. You can make it basically as big as you like. Up to about as much as your graphics card has memory available to allocate that chunk. Basically. Have you got any other questions around it, or is it just that one? Yeah, so it had 0, then 2 nodes, right? And then we looked at them and they were okay. So my question next is like, well, what happens if, like, right? So I'm looking. See what that is. Shoot. Build. Yeah, it's not a lot of memory. Hey there, Krasen, how you doing? So these all point to 0. That's good. Right, these 2 point to 0, 8 and 3. Perfect. So they should be writing their one back there. Oh wait, it's working? No, it's not. This one's not big enough still. It's the bit I'm confused about. So that red one. Right, so what am I doing wrong? Right. It should be multiplying the half dims prior here or something. Ah, right. Doing a silly. Square root of 3. There we go. Some real silly code here. So that can go there. Alright, so let's do that up here. In the actual implementation. Oh, crap. Right, we'll clean this up in just a minute. Let's just get it in here correct. The VAO is indeed a confusing thing. I have no questions about VBO. Yeah, so the VAO, in my opinion, is the most silly thing they added. It probably serves a purpose, but it's just confusing. So, like, it just saves you doing a certain set of operations every time you... Yeah, so it's probably a bit of an optimization for certain people who need that. But yeah, it saves the state in some data structure somewhere internally, so you don't have to keep calling the same functions again every frame. But it is a bit confusing. It's yet another concept to learn. So you don't have to use the VAO. What you can do is you can just go back to the old OpenGL style, but you bind a global VAO that you keep overwriting. So I think you just do that GL bind variable array, and you can do it with a 0 or whatever. Maybe not 0. Or 0 to break the existing binding. Okay, maybe not 0. Yeah, I think you can make one VAO, and you can just keep reusing that same VAO every time you make a vertex buffer array. But it means when you do your drawing, you have to bind your vertex buffers and your index buffer manually, rather than just binding a single VAO right? So you're basically going around the VAO system, if you get what I mean. So, yeah. Unfortunately, it's not good to start with Vulkan. I would like to say yes. There are lots of cool things that you can do in Vulkan. Sweet, okay, we did it. Right, that's in. Legendary. Yeah, so there's lots of cool things you can do in Vulkan that you can't do in OpenGL, but if you're just learning... Ah, shoot. We're out of bounds again. But if you're just learning... you just get into graphics programming, the best thing to do is learn the high level things first. So just get stuff in place where you can learn, you know, how to render a whole frame of a game, right? Learn how to write shader code. And then Vulkan will make more and more sense as you learn more and more about how the GPU works. But Vulkan is very, very complicated. Right, so this one's a bit of a bugger. What happened here? Got a couple of blues, bunch of reds, and then another red. Like, I think we just ended up getting the same sort of color again. Which is annoying. I thought I multiplied it by big prime, or did I? Did I not? For crying out loud. Yes, so we've got 5 and... Yeah. Yep, that all looks good. The leaf nodes are not big enough, is that right? No. No, that's fine, that's fine. Yeah, it's multiplied by the square root of 3, so I'm doing that. But what have I done wrong? I surely shouldn't have to do it in 2 different places, right? Seems pretty insane. So if I do it whilst I'm collecting all the child nodes and boosting those by square root of square root of 3, and then doing it to the parent when it's found. That just seems wrong. Seems like it'll work too well and produces such a big ellipsoid, see? Something's a bit off. I think we shouldn't be doing it this way though. But yeah, it works for this one here. And then it works for... Let's keep going. No, then it fails here. So there's a different problem. So am I not getting the bound? Am I picking up different values, I think? use the bounding box, and then yeah, so let's take a look at the actual values that we're getting out. So these are the ones. So let's print out the center positions of the children of the root node. So we print out and then F, and then we want to do the same thing for the half dims. Now we need to do the same thing again, but in the, oh damn it. Half dims world space. So we need to do the same print again when we actually make the nodes. So here, when I pack them in. So I've got to be careful. I shouldn't have called it child. So node, whatever, right? We should pass in build, or maybe DST node plus sibling index. Yeah, so where is it stored in the final array? And we're going to read it out here. So we're going to read out so node plus child. That'll do it. Awesome. Shoot. Right, what have I done here? What's wrong? Seems legit. Oh, for crying out loud, why is that plus not working then? Oh, have we not put any surrounding braces? Shoot, what have we done? Oh, okay, sibling index is just not. It's defined here. Right. Awesome. Right, so we should be able to see some proper data now. So they're okay to be a little bit wrong, I think, because we quantize it. But I guess if they're wrong, if they're very wrong, then that's a problem. And maybe we're just not. And maybe we can get the data moving around so we can maybe see it. And if it snaps into places, then we've obviously quantized it too much. So here's the values, right? So we've got 0 and 1. This is where the 2. So 1 and 2, because they're the children of node 0, they go right at the start of the array in the BVH tree. All the children are reserved a space right at the front of the tree array. Just so when we say, hey, we've got BVH, we just refer to the start indices of the children, and then off it goes. So the problem is, I don't know. So yeah, so here they are. So as you can tell, these are okay. These two, they're matching. They're matching kind of. A little bit off here, but that's to be expected. It's many, it's a few digits down, or more than a few digits down. Seems okay. Now the half dimensions, this is where it's kind of falling apart. This bottom one goes in as this, but then it clamps out at 1. Right. So the half dim's unorm. Right, so it gets bigger and bigger and bigger. Right, it's stored as... Okay, I see the problem. So it's stored as unsigned norm, which is obviously 0 to 1. And it's just being clamped. And so is the other one actually as well. Okay. It's good to know. So we've got to be careful. So our things cannot go outside the bounding volume, which is to be expected, right? No. Yeah, so the biggest issue is the fact that this box is the from 0 to 1 or -1 to 1. It's the sine norm or the unorm space that every ellipsoid has to be in. Obviously they go outside of it, and then everything just slowly becomes... Yeah, we can't have the unorm greater than 1. So we keep them all within here. Within theory, we shouldn't encounter that problem. What's another way we could solve it? Another way we could solve it is probably... when we do the packing code, maybe... No, but you lose precision. Yes, when we generate our random nodes, we just got to be careful here, right? Don't allow... Wait, yeah, so saying 0 to 1. So we can just say, times by 0.25 for now to make them really small. And that should just fix our problem. But when we make the editor, we'll be able to constrain how things get made. So it will stop you from being able to produce invalid data. Yeah. Cool. I think... Although we've encountered the problem here, though, can you see it? Things just got clamped. They just kept growing to the point where they went above. Yeah, so we should try and stop objects from being... So, right. The idea is if you got center position, you have a maximum size you can be before you go outside the area. So we could take this max half dims, so if you absolute it, If you absolute it, it'll be from the middle to the top right, or whatever, right? And then you can take the difference to the edge of the box at the top right, and that should give you so you ABS that, you then convert it from -1 to 1 to 1 to 0 to 1. So S norm to U norm. So you scale it by 0.5, add 0.5. And then this will give us a value between 0.5 and 1, right? Because we absolute the value. So 0, so from -1 to 1, a value of 0 gets converted to 0.5 when it's 0.5, 0 to 1 point. Right. So a value from 0.5 to 1. So this puts us from the middle to the top right, kinda. So with this, we could tell, we just need to take the difference now between, so at most the half dims can be 0.5 technically. So maybe we can leverage that as well. But yeah. Anywho. So then it would just be essentially you do a subtract with 1 with that result there, and this should be the maximum half dims. So then you just simply randomize it. So you randomize it between that, and you can clamp it. So this will get us a value between 0 and 0.5, and then you can just clamp it there like that. Cool. We should probably make sure that this doesn't go near the edges of the box though with these random ones, so we'll multiply it by 0.8. So that way your values would be just a little bit less than, they'll be a little bit away from -1 and 1, right? Oh shoot, brackets and stuff. Right, so that should produce us a bunch of random ellipsoids that are not going to break the code. Still broken. Oh, Alex, thank you so much for the sub. Appreciate it, sir. How you doing? Thank you, thank you. This one fails. So this one's still clamping, right? Bugger. So those half dims get multiplied still. Yeah, but okay, so all of them, the thing to take note is all of the actual leaf nodes, if you will, are probably gonna, they're gonna be in bounds, right? So if you take, if you have an ellipsoid which tries to encompass all of, okay, we have to do the same thing in the build code, in the GPU code. Whenever we try and produce, I think we have to say, So if we just reduce this a bit. Yeah, so this red one here, it goes out of the boundary. And is it centered? It's kind of centered. It's a little bit off to the left and probably, oh yes, way near. So in this case, would you say you clamp it each side? Like, because as soon as you clamp it, you're losing some here and you're losing some there, right? But obviously if you lose some of the width here or whatever you want to call it, you're going to go in and this child is going to be outside. So you have to be careful. See, it's as if you have to move. See, I feel like if we whatever you clamp, whatever it shrinks by, you have to then offset the center by that as well, so that it should. I still think you're going to create issues where they are the children are no longer inside of the ellipsoid. Yeah. So unless we allow the half dimensions to go bigger. And if we allow the half dimensions to go bigger, is that okay? How many bits do we have? We could allow them to go up to 4, so we keep them constrained within the area, but then hang on a minute. Yeah, I think this might be okay because, you know, when you ray trace against this root node, see if the half dimensions is as big as 1, it means that it is bigger than the box, that everything has to be inside, all the leaf nodes have to be inside. So if it gets clamped at being a size of 1, a half dimensions of 1, then it must mean that it will still be able to so see this one here, this one here is probably like this node here 5 or 6, one of those, and this root node is supposed to be all the way around the outside of this thing, but it's not, and the reason is because it tries to read it back out, and so it went in as like 2.1 on the Y, but it came out as a value of 1 because it got clamped. So it doesn't matter that it got clamped because it's still containing its children anyway, because all of the leaf nodes that it could possibly render live within this, right? So maybe this clamping is not an issue really. because no matter where you place a node, with a half width of 1, that's the size of the whole box that the leaf nodes should be in. So if they get clamped, they will still be able to cover all of the leaf nodes that they're trying to actually render at the end of the day. So all that matters is, yeah, that's good. So, okay. So we will just have to produce a better fitting algorithm in the future. Right, I think that makes sense. Okay. So that's good. Yes, and one thing to take note is Albert did also give me some ideas about how to, he just posted this one like a couple hours ago, how to produce an oriented bounding box from a list of points, which sounds pretty cool because currently our solution is axis aligned ellipsoids. So the leaf nodes can be orientated, but the ones that we've produced right here are always axis aligned. So you don't really get optimal results all of the time. Yeah, so what we need to do is sometimes you could probably rotate the box and get a tighter fitting thing. Yeah. So we'll probably implement that in the future sometime. I just want to take notes of this and drop it in the code base. So to do improved ellipsoid bounding ellipsoid generation from Albert. One, 2, 3, 4, 5. So we'll try this out sometime in the future. Maybe after we've got the BVH traversal working or something like this, just to improve it, because it really will impact the traversal speed. Yeah, we need to do that. Right, so let's go ahead and remove a lot of the stuff we don't need. Right, so I'm putting it into this thing, and then this could just be some local variables, you know? Quaternion. Sure. Right, so we don't need to debug draw anymore. We should be okay. We can leave it commented out though, just in case I want to do that again in the future. What is happening? Right, and this is debug code we can just delete, because that was to display the root node. Okay. So apparently we've now produced the correct tree, which should have all of the child nodes inside of a parent node. So when we traverse the tree, we shouldn't be getting any clipping problems like this, apparently. Wait, we didn't really double check that. Hang on a minute. Put that back. Um, bum 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 bum. Right, so this one's obviously fun. So these blue ones, obviously these guys, right, and this red one is this 3, and this other red one here is this 8, that's fine. So, okay, a bit more complicated. Unfortunately these red ones are a bit the same sort of color, but here we go. So you got these 3 here, 1, 2, 3, and then this bigger one is the root node. Watching this drawing is kind of doesn't like overlapping. Then you got 4 nodes here, which are these blue ones, one blue one there, another blue one here, blue one, this red one is the parent, which is 3 there. So that seems all right. So we should be able to see these basically. Yeah, I think that's all. It's all okay. I guess we'll keep the debug code there just in case. So should we go back to that BVH traversal code and figure out what's going on? So I remember I did a limit. Right, so I think we should double check this code and remember where we were at. And then yeah. Yeah, okay. So obviously each ray is shot through a pixel. In view space, we move into world space. There's this sort of BVH ref that gets passed in. The BVH ref has the root node index in there, but it also has the number of children. So unfortunately, when you build the BVH, you don't know, like, all I need is 2 bits for the number of children. That's all I need. But I don't... But I only know how many children it has when I've finished building the BVH. So I need to store it in a place where I can fetch it. And this BVH ref thing is a bit annoying because from the CPU side, I'm going to allocate a range in a buffer. And then the children count gets figured out on the GPU. So I'm thinking, should I store the number of children inside the tree itself somewhere? Because I don't have a root node. And the reason why I don't have a root node is because, you know, the root node is a special case. It's got a, you know, I could waste some memory and just store it at 0. So that would waste 64 bytes of memory because it's not going to have any siblings. That should be okay. Yeah, maybe I'll just do that, but it will create a level of indirection just to get 2 bits of information. That's my issue with it. Otherwise, each node is going to have to lose 2 bits of information. But maybe there's something we can do where the first node can just have the 2 bits of info. Yes, here's our BVH node. We don't really have space for it. We could maybe guarantee that the children node start index is... you know, we could just take 2 more bits off here. This would be super silly, right? Root children count if if it is the root, if it is the if node index is 0, right? Maybe we can use it for something else, but I doubt it. I think we can do that. That should be all right. And then I can get rid of this node ref thing. I do have this depth thing stored in there though, but I'm thinking about removing the depth thing. So instead in this ray tracer, I want to take a BVH. BVH node start index, but you know, we could have the depth encoded in it. Yeah, okay, I'll keep the idea of the BVH ref. It's kind of nice, but I'm getting rid of the children count thing because it's just creating problems. So we have okay. So when we create this CPU side, we're just going to say node index 0 because that's where we currently put our nodes in the node array, but we're going to be heap allocating at sub portions of that, and the depth is 0, as in the tree depth, not the pixel depth in the scene. So what I would like to do, the children count is stored in there, damn it. Maybe it needs to be in there. So if we store it in there, we can overwrite it. Yeah, so we're going to get the base index and this ref that comes in. We're going to also, we're going to overwrite that children count. So I guess you put 1 in there, but it doesn't matter. BVH ref, and the number of children is going to come from, I've got to make it a new function for that. BVH node root children count, but you got to take it from the root node. But that's going to be stored here. So that's shift 14, 16. So we're just wasting 2 bits on every node, but it means we get less indirection, I guess. Maybe there's a better idea. For now, this is my best idea. Right. So it's taking word 3, shifting right by 14. And adding a couple of bits, then it needs to add 1 as well. Crap. There we go. And then we need to also change these as well, because they take the ref index and pull out the material index or the number of children, or the children start index or child BVH, depending on which node it is. So we have to fill this in properly. So we could always pack 0 in there and then we just all the bits on. That's one way of doing it. At the end, just all the bits on. So I guess you could have a set, or you just mask it, do it like do it like a shift or something. So you say, set root children count. So it'll be like a node dot word 3 or equals count take 1 and 3, and then we're shifting it by 14 or whatever it was, something like that. Yeah. So we just have to call that magic macro right at the end. So we've done the while loop. When we pack our quad tree, we're going up from the leaf nodes all the way up the tree till we reach the root node. Only one thread comes out here. So this is the last thread. It can get the number of children like so. Wait. So that's where it's going to be set. And then you need to get the number of children from where? Where's the root node? Root node's at 0, isn't it? Oh, wait. This is the root node. Dot children count. We have a root node when we build our tree. That's the build nodes. But the destination packed BVH node is nearly that. BVH nodes. This one here. children count roots children count. So this is going to be our first node in the tree. Oh, shoot. Yeah. So this is our first child. First node in tree is actually at 0. I don't have to get that. Right. So set the root children count in the first node in the tree. Which is the first of the root node's children, since we don't have a root node in the packed tree. Maybe we'll change that in the future where we have a root node, because we're wasting 2 bits for every node to do this. So that's the trade-off. So, right, so at least that's being set now. So in our ray tracer, let's go over how this works and correct things as when we need. Yeah, so we start our array off per pixel in view space, pointing through the pixel. We then move it from view space into world space. We get our base Oh, I see something a bit funky. So we've got this base index thingy. Right, how are we storing in the stack? What are we doing? Okay, maybe that's okay. Right, okay, let's keep going. So we've got this stack, right, because the way the traversal algorithm works, and I can't run it anymore, can I? Yeah, I don't think I can run it yet. Oh wow, someone's gonna get blocked. Yeah, so the basic idea is we loop over all the children of a node, test them all and see if we've hit any of them. And the ones that we hit, if they have children, we put them on a stack. But if they don't have children, we do the PBR shading and then keep track of the closest hit and the final color. We haven't got any anti-aliasing at the moment. We can do that in the future. And transparency. We should be able to do something there with this, but yeah. So the node stack needs to be populated with the root node. So you put the root node there. This should be 0. So it was going off into some really random place, because I think what we do is we take the base hit. Yeah. So I want to extract that out. How do I do it? BVH node root children count. So BVH nodes base index. Right. So from that root node, pull out the number of root children, put it in there, and 0 for the depth. Okay. Yeah, so really we could just do with an index, but it doesn't matter. Right. Okay, so that's probably where one of the issues was, is the stack didn't have the correct index. In here it had an absolute index rather than a relative index from the base node index. So we start our stack off on 1, so it's got one element in the stack. We've got this iteration thing, so we don't, we've got a max number of iterations, which is like 64k or something like that. Or it should be. It's only 2 right now. We can up that probably. And while we have something in the stack, go decrement and take from the stack that element. So we're putting out the it's not really a root node index anymore. Bit of a terrible name. But yeah, node index. Should probably just call it a node index. Base node index. Root. Okay. So you also get the number of children and the depth. So if the depth is bigger than the max depth, we're going to break. So I use this, I've currently got it at 2, so I don't go too far at the moment, but it's a way to also catch there's any bugs in the code, we could end up just traversing for ages and it's to stop it from, or maybe doing an out of bounds or something like this. I've got a lot of these safety checks in because if the GPU crashes, it brings down my whole desktop environment. That's just because the drivers are like that, which is really silly. But realistically, if the code works perfectly, you will get a lot by removing all of these safety checks or assertions, if you will. But for now, they're staying in. So here's one safety check. Here's another safety check. If the base node index plus the children's start index, so the base plus the relative plus the number of children, if that goes outside the number of total nodes, we print out a message and return. So it's like an assert. Now, I remembered that I did something in one of the previous streams, and I was thinking about it, and I was like, why did I do that? It didn't make any sense. So the thing is we have a number of leaf nodes for a single BVH, number of instances, and I decided to say, hey, the total number of BVHs is number of nodes times the number of instances. This doesn't make any sense because the whole point of an instance is to share the node data, right? You point to the same node data. So what we should probably have is a number of unique capacity. So what's the number of BVH trees? What's the way of saying it? BVH, I could just call it a BVH tree. So the number of trees that you want to have. So if you have some like animating, mesh, you need to have a copy of that tree for every instance. If it's a static one, you reuse the same tree. So This can probably go up higher now. This one makes more sense. Right, we can put it down to something like... So I want the maximum release to be 3... we could probably put this down to about 1024 number of trees. So where we do this instances thing, that should be trees instead. So that was me being super silly and getting that wrong. But anyway, I think we're back to something sensible. Yeah, we don't have BVH instances yet. That's something we still got to build in the future. We're still trying to get the bottom level BVH off the ground, but things are looking good. So I'm glad we corrected that. So if the children count is invalid, the data is invalid, or return. Shouldn't be invalid though, but just in case. So now we go over all the children. We get the node using the base index plus relative index plus the child index. All of the children sit next to each other in memory. Also, all the siblings sit next to each other in memory. And they all sit in the same cache line. Each child is 16 bytes. Each set of children, set of 4 children at most, is 64 bytes altogether. So that should help with performance, hopefully. You know, we're going to be doing, you know, you pull up one cache line and you just be able to test against all the objects, and the bottleneck will then be actually operating on those BVHs. So BVHs on those ellipsoids on this node. So each node has an ellipsoid. We've got to take it from local space into world space at some point, but that's after. If it's got invalid node type, bail, you know. So this is all okay. We move the array into local space, so rather than rotating the ellipsoid, we rotate the array and translate that. So the ray versus ellipsoid function operates on an ellipsoid in local space where the 0, 0, 0 is where the ellipsoid sits in space. It's axis aligned as well. And then we say we've got a hit. If we're a parent, we're going to... this is where we needed an else statement. Was drawing it anyway. Yeah. So realistically, we'll have an else statement, but I'm trying to debug the tree and make sure it works. So I was drawing it shaded as I went at each depth. So yeah, this should have an else statement. So if it's a parent node, we're going to add it to the stack. So we push onto the stack, right of overflow, error. And we put the relative node index on there. Yeah. Let me double check something. Destination node index better not be... It's relative, right? I need to get this naming a bit better, to be fair. Yeah, it's relative. Sweet. From a start index. Okay, back to where we were. So put the relative index in there, get the number of children, put it in there, and put the depth, which is node depth plus 1. Put that on the stack so we come back to it later. Now this should be in an else statement if it's a leaf node, but we're just saying, hey, if we're the last depth to be accessed, do the PBR shading and report closest hit. Okay. And then render the pixel. Wait. Yeah, render the background if we've not got a hit. An area if we reach max iterations, but that's disabled right now, and then we put it out to the screen. Cool. So I think that seems sensible now. So if the stream dies, I'll be right back. It's the AMD drivers, they kind of crash sometimes if I access out of bounds, but hopefully not. Right, we're still here. And my camera's so damn slow because I changed it, but we've got to cut. This doesn't look good. Oh, for crying out loud. Look at this. So we see the ellipsoid. And then it cuts. Not very nice. It could be to do with this scaling thing that we're doing. I'm not sure though. And maybe we can debug. Right. That's not an ellipsoid. It gets cut still. I want to do 50 pull-ups tomorrow. Sweet. Do it. Are you interested in your pull-ups? Is that your thing? So I don't know if this is the... Right. Crap am I seeing? So I think the part of the problem is that they're all overwriting each other, and it's a bit problematic. We should try and render the debug shapes over them. But yeah, I'm not doing the closest hit anymore. I just set it here. I didn't say if this is... Oh no, I did. No. So here I need to say if it is the closest hit, right? Yeah, I think it is being cut, but we debugged, drew everything and fixed all the problems, but it's... So we've debugged, drawn this tree with the debug shapes, and it should... There isn't... Those problems don't exist, but they apparently are. So it's a bit bizarre. Looks kind of cool though. Maybe we should keep it, you know. This is the way. Not all at once, of course. Oh, okay. Pull-ups is great. Yeah, I used to do pull-ups a lot. I don't do pull-ups anymore though because my shoulders. Yeah, it's too heavy. Too heavy duty stuff. I just lift weights with my shoulders like that now. That's what I do because my body weight is too heavy. Can feel my joints not liking it. Yeah, just make an excuse infinite CSG. Yeah, exactly. Zoom. Look at that, some magic stuff going on. Zoom. Anyway. Bananas. So what would be nice is if we draw the debug tree on top of... I don't need this printing though, but I guess it's okay. Draw the debug tree on top. Where is it? Where's the node? Hang on a minute. Thank you, Devros. Yeah, we've been yeah, I implemented a kind of hollow looking... Right, so we don't see anything there. Oh yeah, that's because I'm only drawing depth 0. Yeah, I didn't want it to go crazy town, so I stopped it at a certain depth. Oh yeah. Hang on a minute. I don't know if... What's your bench press max? I've not really benched before. I just lift 10 kg weights, so I got one in each hand, and I'll do all sorts for those basically. I've tried upping the weight a bit, but my joints are not necessarily great at that either. But I'm trying to gradually up the weight. The problem is that I've got to stay consistent on it, because if I don't, yeah, the muscle won't. Yeah, but yeah, I need to sort of make sure I rest well, do the exercises properly, and yeah, keep doing it regularly, and then I could probably up the weight. But yeah, I kind of have I don't know what condition I have, but my joints feel quite loose sometimes, and they end up yeah, I just got to be careful with what I eat, and try not to put too much strain on my joints. That's it basically. Oh, and obviously exercise every day. But yeah, so I can't lift too much of a heavy weight and exercise with it, because my joints would just ache like crap and it would just be a waste. So yeah, I typically just use some 10 kg weights and lift with those. It's doing well. I've started to do a lot better when I've decided to eat more food. And actually put more weight on. So yeah, things are improving. Because I think the biggest problem with me is I eat so much food and then I just don't put on weight. So now I have breakfast, I have a good breakfast, and then I snack. I have a good lunch, and then I snack, and then I have a dinner. And then after, on stream days, I chill after stream, and I'll go and eat more food. And that puts weight on, but it doesn't put too much weight on, and it's good. Yeah. It's kind of insane how much food I eat. I just don't understand it. So now I'm putting on weight, but yeah. But the thing is as well is I don't like to eat like I eat a good plate size and I get full. But it's I don't want to eat too much food in one sitting because then I'll like stretch my stomach out or whatever, and I'll have an appetite for tons of food in one sitting, and that's what I want to try and avoid. So I try and sort of space it out throughout the day and not create that problem. That's the hope. But yeah, anytime I go out or go around someone's house, I'm like, always bring snacks with me so I always can eat. Yeah, it's one of those. I know it's the opposite problem to most people. It's really, yeah. It has its own downsides. It's a struggle. It's a struggle. Yeah, and also I know that like if I eat too much sugar, my joints will ache more, so I have to keep that down as well whilst trying to eat enough food. So basically just trying to eat more fat and protein, and obviously I still eat carbs, but I just keep that down. But yeah, it's always tempting though to eat more carbs. Right, so what we're trying to figure out, so we put the max node depth at 1. We should only render the root node. So let's take a look at that root node. Right, I'm not rendering the root node. I'm rendering the 2-child. Excellent. Things. This is the visualization that we should be seeing. But in right, so what made the other nodes go weird? I think it was an out of bounds check, maybe. Yeah, it's an out of bounds. Something about that. Must have been. Right, so we're gonna debug draw the tree now and watch it overlap with this. What do you mean by how much is too much for you, Lipo? Sorry, I didn't see the message when I was talking or whatever. What is that in reference to? Focusing on coding without gaining weight when I stop going for bike rides, etc. Yeah. I see. Yeah, I always just go on walks and everything, and I stopped doing that now since I moved to my new place because the walking is just terrible. Like, we're in a housing estate or around a field which gets boggy, so I've just got the excuse of not putting on some wellies, basically. Right. So we can't see them render at the same time. Well, we kind of can. But they're there. There, and there. You can see it. Yeah, so these are... There's that node there and that node there being rendered. Cool. But yeah, we shouldn't be rendering this node though, right? We should be rendering the children. But I'm just testing going down to level... the second level, basically. 1 and 2. So I don't know what the crap I'm rendering here now. Hard to really tell. Why is it so transparent as well? Well, it's not transparent, is it? Right, the reason why it's not going outside there is because it got clamped to be inside the box. And outside the box to be the half dim is like, it got clamped like this, I think, right? To be a value of 1. And that's the reason why it's not the same size. But that's cool. That's fine. Right, I think this is working. So let's disable this debug drawing stuff. Let's just look at, to make sure we've got this, the right number of nodes, right? So sugar, how much to eat? Well, you just get a feeling for it. You know, it's taken me like probably 7 years to get a feeling for over time. Well, to remove 7 years to remove the temptation of eating sugar. Like, I think I've mastered it now. If I have a bad day, I'll go and get a chocolate bar. But besides that, or, you know, but in terms of how much to eat, it's basically 0. But in terms of like carbohydrates, I'll just have them with dinner, you know, the rice or the pasta, whatever it is, and maybe I'll have a bit of bread for lunch. But the rest is fat and protein, I think. But yeah, tons of like, sugar's very hard to come off of. It gets to the point, I think the first level of it, if you're really addicted, is you walk past an aisle in the shop and you have to go and pick something up. And then the next level of it to get past is you see someone else having it, so you convince yourself saying, I can have it too. You know, and that first stage is hard to get past, second stage is very hard to get past. And then the third, or maybe there's like a 1.5 stage as well, and that is, you know what, I've been good. I haven't had it for a month. I'll have a bit of sugar now, or whatever it is. And you have it, and then you'll be like, you know what, that was so nice, I want some more. And you have some more. And then you've just then brought it back into your diet and you've just snapped right back. So I think there's like those three levels of things where, yeah, you got to be careful when it comes to habits and things. Yeah, we're rendering balls. Squished balls. If I'm focused on a project, I really find it hard to tear myself away from a machine to exercise. I know, right? Yep. Yeah, walks are really good. I used to go on so many good walks. So many big walks, you know, put my headphones on, listen to a podcast or something. And, you know, or thinking about things and just, you know, thinking about things I want to do. Getting excited. Right, so we're just looking at this node, these 2 nodes here basically, and just, or this level of nodes. So we should have 4 here, right? We're seeing it. There's 4 of them. Right, things are working. But we should go down to the next layer and see that. Yeah, I think that you just have to get into the habit of exercising, isn't it? You know, whatever that is, like however you do it. Maybe you see, what I find the easiest way to exercise is you have something to watch. Put on whatever it is, Netflix, YouTube, or have a podcast. I go through so much content. Like the other, I think in a couple of months or whatever, I watched the whole of Star Wars Clone Wars for the first time. And that's just because every time I exercise downstairs with my weights, I put on Star Wars Clone Wars and I watched, the whole TV series over a couple of months. So I find what makes it easier is just putting on something you really enjoy and just doing the exercising. And also, if you can exercise from home, it's the best thing because you don't have to get into the car, go to a place, pay for it, and like getting in the car and going there is a lot of effort. But I guess as soon as you get there, you're probably going to put in a lot of good work. So I think you've just got to have that tendency when you're at home to just stay in that room watching that TV and exercising. Oh yeah, ice cream. Or nice cool drink. They just do 3 months of walking every day, health eating plus project progress. That's a rare to do all three simultaneously for me. Nice. I thought about trying to take some podcasts somehow related to what I'm doing and dictate notes or something. It's just one idea. It's just talking about Rust compiled times. 20 seconds, I can feel like eternity. Yep. I didn't realize Rust compile times are that bad. Probably all those generics they got, isn't it? In the standard library. I've been working out for the past 4 months, mainly due to treating my workouts as a must, not as a should. It takes any motivation out of the formula. Yeah, definitely. Yeah, it definitely must be a thing you don't excuse yourself from. Right, so let's up this depth to 2. So only viewing stuff 2 layers down in the tree. And we'll keep upping this number and hopefully we don't crash and burn the GPU. Right, here we go again. So we should only be seeing the 3 nodes. See, these ones we're not seeing them. See, at 3 it starts failing. Is that because yeah, why does 3 start failing? So 2 seemed okay. No, what's going on there? No, it didn't. Right, okay, one seems okay. My mistake. Okay, so I guess these shapes aren't big enough and they end up clipping. Oh, maybe it's okay going down the tree though. Because the leaf nodes are probably so small. Yeah, maybe it's okay. Let's keep going. Let's go to 4 nodes and see a depth of 4. Let's see what happens. Alright. Right, so I think it's okay if we get clipping, but if we get clipping on the leaf node, it's a problem. You know what? Should we just try and render the leaves? I think we successfully... what's the max depth of a tree? 32 in it? 16? See what happens. Right, if the stream dies, I'll be right back, but it should be fine. Right, so not seeing any leaf nodes, that's all. We're not seeing the leaf nodes for the simplest tree? Oh, of course. Because this damn if statement. Right, this one is if the parent is equal to... Sorry, the node type is equal to the bottom level leaf. Right. So I don't see anything here. Whoops. Right, so we see them here though. So let's increase. We see one leaf node, but we're not seeing these ones here for some reason, although we should be, right? I didn't think there was any issue. So it could be the traversal code. We could... So for every single node that is a parent, we could draw... There's that... Verse ellipsoid outline. Yeah, I don't know if we'll pass it though. So we could say, well, if you hit the ellipsoid, draw the outline if you're the parent or whatever. Wait, why am I doing this? We could just do draw 3D. Oh no, because that will mean it will do it for every pixel, so that's not good. But yeah, so we want to do it for every pixel, and right, so this is purely for debug purposes. Yeah, so I think in future an optimization could be we don't do expensive calculations every time we hit an ellipsoid. We just do quick cheap ones, like adding it to a stack. This bottom level hit should be saved for later, I think, where we can batch them all into one set of we can batch them all into one loop that processes it, such that you get less branches which diverge, because if one pixel touches the parent node and one pixel touches the bottom level node, it's got to do all the PBR shading, which can be quite expensive. and you have a bunch of inactive lanes and things. So it's probably best if we batch those into some other processing section at least. But yeah, so we're trying to draw some outlined ellipsoid here for debug purposes. Right, my rotations are... Right, I need to look at that rotation thing. Right, local from world rotation. World from local rotation. World space. So run it. Cool. Then you got your world from local rotation. Right. So how much of this is going to work? Center pause. World space. Right, why is that in view space? We don't need to bring it to view space, do we? We just need the world space T. No normal yet either. Yeah, then final color it's called. So I guess we could do a nice little nice color thing in it. What are we chucking in there? Some in right, so that should produce a closest hit depth. So that should produce an outline for parents that we hit as we go down the tree. Should be pretty sweet. Right, it's they're a bit skinny though, but I don't know. So it hits this node. Right, we're seeing it hit it. This is this left-hand side one, but is it not traversing? Oh yeah, I just realized. I'm an idiot. I stopped the max number of iterations. Past Henry, tripped up, current Henry. That's bad. So let's run this again, hopefully it doesn't crash. Right, we overflowed the stack. So it didn't render anything. So we're not overflowing the stack here. But let's increase the number of nodes. Wow, we overflow the stack with that little? Can't be right. Don't do it. Right, stream's still going. Okay, so apparently, yeah, obviously outputting that per pixel is just way too expensive. So there's a lot of data coming out into the pipe, into a buffer and overflows. So that's why the frame rate tanks. My concern is this node stack. Way too much. Yeah. See, how does that overflow the number of nodes? I think there's a bug in what's going on here. Because how is this overflowing 64 node stack? We don't even have 64 nodes. Something is definitely fishy. Ah, shoot, what did... I added one. What we need to do is add one after. So I'm not even trying to traverse the next node. Because when it pulls it out... Right, so we're still getting the problem. We've got 64 nodes on the stack. Right, so we're starting to see something. Why is it painfully slow? I think we could... get that down. Right, when we put 5 nodes, it just started getting painfully slow. Right, we're overflowing the stack there apparently. That's a clear bug. We decrement one on the stack. But here we're gonna put it on the stack. Right. Node is the child node. So what we should do is follow a pixel. So we should say wherever the mouse is, follow, do some printing. So what we'd like to do is say, is basically view the stack, right? Like what's going on. So you want to do something like if is mouse at, this is just a little thing we've got in the shader. So we've got a global called mouse position in shaders, and we just put a pixel coord in there and we know if the mouse is on that. So it's nice and handy to be able to just say ucoord. I think I've got to float cast it. No, I don't. Good. And then we can do our lovely prints. So what I'm hoping to do is just print out the start indices for now. Yeah, so we should follow this per, wherever the mouse is at. Let's go. So, and we should have a print that's happening per frame, I think. Right. Painful. It's so slow. You kidding me? What's going on? So if I just put a print in here. So So I'll just put it in between each frame. So we should, if we just, we might keep visiting node 0 or something. Right, as soon as we start getting some depth. Ooh. Ooh. 65,000 of those? That ain't good. So let's put that down to 16 so we get some sensible frame rate. But yeah, I think we're getting the same node off the stack. It seems like that, doesn't it? Yeah, so this one's only rendering 2 for now, that's fine. Right, so hover that there. There you go, all 16 of them are... So apparently it's just trying to render the root nodes over and over and over again. What did I do wrong? Right, so we want to say is mouse over. Here instead. And I would like to change that out to this one. And we'll comment out this one here for now. So when we add it to the stack, we're going to be seeing what the value is. So into the stack. Wait, why are these adding to stacks? Oh yeah, this one should be. Sorry, I was thinking of some other one. Add 0. Well, that's wrong, isn't it? So the children's start index appears to be wrong, the way it's being assigned. So why is my node... So let's go into the pack. But why was we able to go down the tree then in some cases, like... So there's a ref index. You know, if it's a parent, it's this destination node index. So shoot. I think, is that a typo? So for this tree, for this ellipsoid, if it is a parent, then it has children. Its children are at node index. Right, so it's pointing back to itself. I don't know how it carried on. Right, let's see how that works. Oh, we're seeing more nodes now. This is good. Excellent. Let me revisit that tree thing. Right, so this is mouse at stuff. I think we can delete it now. Yeah, I think that's sensible. We can up the limits a bit. So the limits had a... Let's put back that 65,000 limit. And off we go. Did I not hit compile on that one? Alright, here we go. Okay, so they're still clipping a bit. That's cool, we can look into that. But I think we've got progress now. Right, so they're rendering okay. A bit weird when you go inside the object. Something to look into, but we're actually not going to have that problem in this game, because I don't think your camera's going to go near the objects, but it's probably good to fix that anyway. Right. Okay, so if your camera's... That's the clipping problem. If your camera is near the object, it does clipping. Okay. So I think... No. The bounds of that thing is just not right. But yeah, it is right that it does clip, or it completely doesn't handle inside the shape. But there's something weird with that thing there. That's cool, right? So you've got 6, right? So 3, 6, good. So here's 7, 3, 6, 7. Here is 4, 3, 6, 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. So we should see 8 nodes. Right, I think I see them all. 1, 2, 3, 4, 5, 6, 7, 8. Boom. So I think this is working fine, except for the clipping. And this is a nice little artifact. I think I want to keep this, right? I think we can get some nice... See, if the ellipsoid is perfectly flat, it does this. And yeah, I don't know. We should probably test what it does on different GPUs, but if it all works the same on different GPUs, it might be kind of fun to use as some thing. But anyway, there's 9 of them there, I think. We should look into that clipping problem again. But yeah, we're able to up the number of nodes. There's 64 nodes. That's cool. Things are coming together. There we go. 64 nodes. But yeah, we've still got a clipping problem. It's not good. So we're going to draw those parents again. We've got that lovely switch. And this should draw the outline. They're a bit skinny, so let's make them a bit more chunky. Just a little bit more chunky. Still a bit skinny, but there we go. So these are the parent boxes, and those are also getting clipped. So let's find a minimal sample where we have a parent. And let's see what we can... Yeah, I don't think that's... Right, there's our problem. So we're hitting the ellipsoid, therefore we can see it. But... And we're hitting this ellipsoid. Right, okay. This one belongs to the blue one. This belongs to the blue. Whereas these two belong to the red, right? These two belong to that. This one is probably like 7 or 10 or something. I don't know, one of these guys. So for some reason, this doesn't produce the ellipsoid we want. And I think it's because of the boundary clipping problem. I think it's because the half dims gets clipped. We can make it so that it can reach a number of 2. and that might be okay. Well, it'll end up reducing the precision though. But we should be able to, if we half the precision, we should be able to double the number of, or the range. Double the range. It's something to think about though. Okay. So we've got a BVH node. So the problem is that half dims is getting clamped. So maybe we could say, oh, we know you're going to get clamped. So, no. Or while we're building the BVH free, we could say if the half dims is going to go outside the box, yes, the problem is when you take this value, it's unorm, so 0 to 1. If it goes outside that range, it just gets clamped, and so therefore it's not going to fit everything in that it's supposed to fit in. In reality, it's probably, it might not be that much of a problem. So there's like a center position as well, and if you clamp, yeah, the fact that it gets clamped is it's problematic. I think it's all it needs is a maximum value of like 1 times square root of 3. So basically it needs a maximum value of 1.7. That's all it needs, and it should be fine if it gets clamped then. Because the center position has to stay within -1 to 1. Or the ellipsoid should exist in between -1 to 1 in local space. So half dims should be able to support up to 2, basically. So where we do the packing, say if we said unless so I got an idea. So if we have a box, where this model lives in local space, it's actually a cube, right? The furthest a shape could be is up to the end. So a leaf node that we're trying to draw, right? An ellipsoid that we're trying to draw. But the ellipsoid has to be able to cover. Right, so let me draw a better cube. There we go. So the most a leaf node can go to is to an edge, right? But a parent node is allowed to go outside. So the most it can go outside is such that its radius or its half dims is 0.5 along each dimension, right? And its center position will be here. So realistically, we should be able to save space. So the most so it has to get, rather than being a clamping, it has to move closer and closer to being this shape, right? So if you have a parent which is supposed to go like that, then, well, maybe that's fine. That one's okay. If you have a parent which is supposed to be bigger for some reason, I don't know, like that. That's a really good example. So the center position would be here, and maybe it'll go like, it's always a little bit bigger for some reason. We might do something like that, right? Still kind of out of bounds. Yeah, it ends up being a bit bigger for some reason. Let's just do that, because this is how it works out. So what we would have to do is, you can't just reduce the half dims. You have to nudge it as well. So maybe you nudge it because if I just reduce the half dims, then it's a problem. Because you could have something which is like here, and it will just cut. You know, the child will be outside. So if you reduce the half dims, you find the edge where it's outside the box, and you nudge it. You nudge it in the opposite direction. So we could probably do something like that, where, so you got the center position and the half dims. You should say, well, if the half dims is greater than 1 across any dimension, you look at the center position, you see what side it's favoring, move it in the other direction by the amount that we're clamping off, basically. So I think that should do it. Amount to remove. So most we should, so the clamping is happening at 1. But yeah, at most all you need is 0.5. A half dims of 0.5, that's the most you need. I think. But let's just give it a go. So amount to remove would be something like this, take 1 max. To subtract 1 from that, and then you max it with 0. So what you're saying is, you know, how much is it overshot past the value of 1? Then you want to move. So it's a half dim. So wherever the center position is, you move. If it's negative, you move it more positive. So you take the sign. So the move direction is just the negate of sine. Across each component of the vector, right? X, Y, Z. And then you move it by that, and then you shrink it by that as well. So you move, you say amount. So what happens if your thing is, so the problem is you don't want it to move past the center. If your ellipsoid is on one side and the amount to remove will move it over, because you can end up at a case. So your ellipsoid could be here like this or something. I don't know, it could be like that. Where it's here, but you need to move it that way or something like that. And you end up like overshooting it. So you end up overshooting it, and then it was in a worse place than it was before. Just on a different dimension. Or in a different sign or something, I don't know. So the amount to move also needs to be restricted by, so you need an amount to move, and this would be based on the minimum between this and the ABS value of center pulse. So you're saying like, don't remove more than, so it puts me past the center. Then you're saying, then you need to apply the move. And then that's it. Because the rest will just get clamped. Center positions norm equals add amount to move. Wait, amount to remove. And hang on a minute, why am I doing it in a direction? Do I need to multiply it by that direction? Yeah, that's right, isn't it? Right, that should be the fix, I hope. We'll find out. Right, we've still got clipping. Didn't fix it. But is it better? That's the question. Seems alright. What's the next one? Right, so this problem is still here. Still clipping. That didn't seem to fix it at all. Oh, for crying out loud, stupid laptop. Ah, KDE piece of crap. I've been locked out of my laptop for 5 minutes because I entered my password wrong. Apparently. 5 times when I just put it in once. Obviously didn't reset the counter. Ah, piece of crap. Anyway. Yes, I'm not sure what's going on here, so take the sign, the opposite of that. Then you pick the minimum between the amount to remove, that's the amount to move. Okay, so we could draw a vector to say where it is supposed to move. We can just draw vectors. Draw 3D vector, world space, center position. With the vector, the thickness, the color, Z test. So see how that looks. Right, so there's a vector over there, I can see it in the middle. Right, it did move. That one did move because it went out of bounds. It moved to there from there. This one actually moved down. So is this thing out of bounds? But really, you need to it needs to move up to get in here. But how? So we should really draw that bounding box because I can't see anything. There's a bounding box here that we should like to draw. And this is the box that it's trying to okay. It's trying to navigate around. Right, so this blue one now fits nice clamps in there. At least on that side it does. This side it doesn't. We should try and see where it was before actually, but yeah, the box I guess was bigger. You know, let's draw the box it is before the change. Right, let's not apply the change. Yeah, but I want to see. Yeah, the box before the change, before it gets clamped also. Alright, which one is it? Not that one. Right, it's this one here that was out of bounds. It's a bit more involved with what's going on here. But yeah, so this blue one that we're seeing and this outer red one, that's what it used to be. Is that outer red ones that used to fit this. But its Y dimension was way too big. It's bigger than 1. So it had to move to fit. How is that bigger than 1? Yeah, so it's saying, right. So my coordinate system is -1 to 1 inside this box, but the half dims only needs to go from 0 to 1 instead. But yeah, so 1 would be at the half size of the box. So if it's the size of 1, it'll go from the top to the bottom. So when it gets clamped, the most it could be is from the top to the bottom. So it never... Yeah, that's problematic. Because obviously if you have a sphere fits with a radius of 1 fits inside of a box. But it never covers the whole box. So unless we make it that... Yeah, so our half dims has to be able to go up to a range of 2. And then it's probably going to be fine. Then if it gets clamped, it doesn't matter. Right. Okay, so something to do next time. We're getting close. The BVH Traversal. So I don't think we need this. It was a nice idea, but I think it... You know, we'll leave it in there. We'll come back to it. It's a nice idea though. So yeah, we're getting super close. We are traversing the BVH fine. we've just got one more clipping problem to solve with this half dims thing, and I want to solve it properly because we've got so many packed nodes. Sorry, we've only got so many bits within the packed node. And I want to make sure that we're not got another way to solve it. Yeah, so Sunday stream we should have this traversable. Then I might do a recap and record a video for YouTube, because we got to a place where we've built this BVH all on GPU and we'll be traversing a bunch of nodes. Maybe we can up the count from 64 and make it bigger, just so we can see it handle that, I guess, but I don't know, this seems to be alright, so should be able to do higher. But yeah. Right, we're getting close. It says Discord if you can come and hang out in the meantime. And there's a YouTube channel if you want to catch up on the devlogs, and there's a VOD channel if you want to catch up on past streams. Let's find someone to raid. So our next be on Sunday at... Sorry, not Sunday. Thursday at 7:30 PM GMT +1. And then Sunday at 6:30 GMT +1. Alright, see who's on. Alright, sorry, Jessica. Okay, guys. Thank you all for coming. Appreciate it. Good to see you all as usual. Have a good Wednesday, and I'll see you all Thursday. Catch you later.